Hello, this is the third lesson for Unit 5A. We're going to be simplifying binomial expressions. You can see your objectives for this lesson. We're going to talk about adding and subtracting radical expressions. All right. Now, when we multiplied radical expressions, they had to have the same index. Okay. When you add or subtract, they need to have the same index and the same base. They both have to be the same in order to add, because what you're doing is essentially combining like terms. And if it doesn't have the same base and the same index, it's not a like term. All right, so let's look at these examples. You've got 2 times root 3 plus 5 times root 3. All right, these both have an index of 2 and a base of 3. I can combine these. All right, remember you're adding. All you're doing is adding. So there are 2 root 3's and there are 5 root 3's. You're adding them together, so that means there are 7 root 3's. It'd be like saying 2x plus 5x is 7. Okay. The second one. So you look at this and you say, all right, I've got the same index, that's good, but it's a different base, I can't do those. But you can take the fourth root, or whatever root you're working with, and see if you can find the same base that way. Let me show you what we mean. So we have that negative 3 on the outside. I can reduce a fourth root of 32. Because 32 has a factor that has a perfect fourth root. Okay, I could take out 16, and now I've got negative 3 times 2 times the fourth root of 2 plus 2 times the fourth root of 2. Now I'm going to simplify and combine. So I've got negative 6 fourth root of 2 plus 2 fourth root 2. Negative 6 plus 2, we get negative 4 fourth root 2. Okay. So before you just dismiss it and say, no, sorry, different base, make sure you can't reduce it by whatever root you're given. Okay? How about this last one? I have the same base, but I don't have the same index. I can't do anything with this. Okay? So we can't simplify anymore. Or already simplified. Okay? All right, so try the 3 below. Try the 3 practice, numbers 1, 2, and 3. And I'll have the problems when you unpause the video. All right? So very similar to the examples. 6 times the fourth root of 5, negative 10 times the cube root of 3, and number 3, same as the example, different index, cannot simplify these. Okay? So think about that for a minute. Is that correct? You saw the different index and you said you can't simplify it, right? But take a closer look. What is the fourth root of 16? 2. What is the cube root of 8? 2. Okay. 4 minus 6, negative 2. Okay, so be careful with that. Make sure you can't reduce the radicals first. Okay? All right, now add and subtract binomial expressions. So very similar to what we just did, there's just a lot more going on. Be careful to distribute your negatives. For example, 3 plus cube root of 2 minus 5 minus a negative, so plus 3 times the cube root of 16. Okay? Try to combine like terms, see what we get. I've got 3 minus 5 is negative 2. How about this 3 root 2 and 3 root 6, or cube root of 16? Cube root of 2 plus cube root of 16, can we do that? First response might be no, but cube root of 16, I can change that, right? I can take out an 8. Right? So this actually becomes 3 times 2 cube root of 2. Because that 2 comes out, that 8 comes out as a 2. Okay? So I've got this root 3 here plus root 3, excuse me, I keep saying that, cube root of 2 plus what we have from our other expression. So it's negative 2. This 3 times 2 is 6. Plus 1 is 7. So plus 7 cube root 2. We want to write this with the rational term first, followed by the irrational term with the radical. Okay? Go ahead and try number 4. All right. So number 4, pretty straightforward. It's already the same index, already the same base, just combine like terms. Negative 5 minus 2, 4th root of 3. Okay. Adding and subtracting, pretty straightforward. You just need to apply what you did above with making sure the index and base is the same. Multiplying binomial expressions, all right, also known as foiling, or you need to use the FOIL method to do this. Okay, but you're going to get some different numbers you may need to simplify. Okay, all right, so I'll do both of we'll do both of these together. All right, so the first term here, 6, outer term plus 2 cube root of 4 minus the inside here 3 cube root of 4 minus the cube root of 4 squared. Okay. So let's combine like terms here. I've got 6 minus cube root of 4 all right, so this last one you get, this doesn't really simplify. Cube root, you could write it as a rational exponent, but that's not really going to help us. Okay, so just leave it. So you get negative cube root, negative, let's leave that, cube root of 4 squared. If it doesn't simplify, just leave it. Okay, in this particular case, I can't get rid of this radical, so we're just going to leave it. Okay. All right, so the next example, 1 plus the square root of 6 squared. All right, most common mistake, everybody just wants to do this. They do 1 squared, and they do square root of 6 squared is 6 is 7. Think to yourself, is that correct? What does this squared mean? What are we going to do here? Okay? Do not do that. Okay? This means 1 plus the square root of 6 times 1 plus the square root of 6. we're still going to be foiling. All right? First, 1 times 1. Outer, 1 times root 6. Inner, 1 times root 6. Outer, square root of 6 squared. Okay, well, square root of 6 times the square root of 6 is just 6. So I'm going to get 1 plus 2 root 6 plus 6. I get 7 plus 2 root 6. Okay, very different answer than what you got otherwise. Okay, you won't get any partial credit for this. Okay, it's just completely the wrong way to do that. Just be careful before you start getting into these. All right. Okay, so that's multiplying. All right, dividing, also known as simplifying or rationalizing the denominator. Okay. All right, so binomial expressions in the form of a plus or minus the square root of b will have a conjugate the same way we did with imaginaries. All right. So the first thing to be able to do is identify what the conjugate is. All right. So if negative 4 plus root 2 is the denominator, what is the conjugate of that? Remember, all we're doing is changing the second sign. So the conjugate of this is negative 4 minus root 2. Okay? So what's the conjugate of the next one? You have 3 minus 2 root 5. So the conjugate is 3 plus 2 root 5. Okay? All you do is change the second sign. Or just change the sign of the irrational term, because you have a rational term here and you have a irrational term there. Change the sign of the irrational term. All right, so how do you use this? We want to get rid of this radical in the denominator. Okay, so you multiply the bottom times the conjugate, and then you multiply the top times the conjugate, the same way we did with imaginaries. Okay, so you're foiling the top, and then you're foiling the bottom, and you're simplifying. Okay, so let's do that. All right, outer, or excuse me, first on the top, so negative 5. Outer, negative 5 root 2. Inner, negative 3 root 2. Last, minus 3. Root 2 times root 2 is just 2. All right, that's the top, and then I'll do the bottom. All right, so similar to what we had with imaginaries, this middle term is always going to cancel out. All right, you'll get 1 plus root 2 minus root 2 minus square root of 2 squared. Okay, so this all simplifies. These become 0. On the top, I'm going to combine like terms. This is negative 6. This is just negative 2. All right, so I've got negative 5 and negative 6 is negative 11. Negative 5 root 2 minus 3 root 2. Negative 8 root 2, and then on the bottom, 1 minus 2, negative 1. Now this is correct, but we'd like you to change this. Okay, So you can multiply the top and bottom by negative, divide by -1, however you want to look at it. The signs on top are going to change. Okay, so it's just going to be 11 plus 8 root 2. Okay, so we're simplifying a radical expression using conjugates. All right, we're rationalizing the denominator. Okay, go ahead and try number 5. All right, lots of steps here, but just take your time, do one step at a time. Don't try to do things in your head. All right, you get to the bottom here and you say, well, Mr. Ho, you left the negative down here. Well, we changed this one because it's a 1. Okay, and we can simplify how it looks. I can't really simplify this expression anymore. I could make the top -14 plus 2 root 3, but then the bottom is still a 14, so I didn't really change much. Okay, so we'll take either. So if you did that, that's fine. All right, so that is simplifying binomial expressions, multiplying, dividing, and adding and subtracting. All right, so next class, you'll practice some of this, as well as do a review of the previous material, and then your test will be after that. All right, we will see you then.